Hi there, Joshua here. Before we start today's lesson, I thought I'd quickly go over something called the difference of two squares. You may have done it before. On the board I've got two squares drawn, and if you notice, this one's red and this one's green. So that's it, the difference of two squares there. So let's get on with the lesson. So welcome to this lesson on solving trig equations. I'm going to be solving lots of different equations today that involve sine, cos and tan. At the end of last lesson I drew the three trig graphs, and here they are, the graph of sine theta, cos theta and tan theta. Now I'm going to show you two methods today for solving trig equations. The first method I'm going to show you uses these graphs. And then in the main part of the lesson I'm going to show you another method, a quicker method, where you don't have to draw graphs. But to start with, let's solve some trig equations using these graphs. So let's start with some really easy ones. Let's do this one. Let's do solve sine theta equals 1, looking in the range from 0 degrees to 360 degrees. So looking in that range, which angles have a sine value of 1? So which angles in this range from 0 to 360 have a sine value of 1? Well, hopefully you can see that the only angle in that range with a sine value of 1 is 90 degrees. Sine 90 is 1. So that's the only solution to this equation. So that was easy because you could just read it off the graph. Let's do another one that you can just read off a graph. Let's do solve cos theta equals 0. And let's look in the range from minus 180 up to 180. So let's solve that equation. So we're looking from minus 180 to 180 in that range. I'm looking for angles with a cos value of 0. Well, actually, there's more than one solution here. There are actually two solutions. Here and here, the solutions are minus 90 and 90. So there are two solutions, minus 90 degrees and 90 degrees. They both have a cos value of 0, and they're in that range. Of course, there are other angles with a cos value of 0 that are out of that range. So these are the only two solutions in that range. Right, let's do one for tan. Let's solve tan theta equals 0. This time looking in the range, let's go from 90 to 450. Let's go from 90 to 450. Solve that equation. So which angles in this range from 90 up to 450 have a tan value of 0? Well, you can see that there are, again, two solutions, 180 and 360. So the solutions are 180 degrees and 360 degrees. They were quite easy, so coming up next are some slightly harder ones. Right, so here's a slightly harder equation perhaps. Solve sine theta equals 0.5, looking in the range from 0 to 540. The reason it's slightly harder, perhaps, is because you can't just read it straight away off the graph. We're going to have to use the calculator to help us out here. I mean, you can get an idea from the graph where the solutions are going to be. Imagine drawing a line at a height of 0.5, like that. So 0.5. You can see there's going to be one solution roughly here, one solution here, one solution here, one solution here. But to get a solution, you need to use the calculator. You need to press inverse sine 0.5. So if you press inverse sine 0.5, the calculator will give you an angle with a sine value of 0.5. And actually, when you press inverse sine, it gives you the angle closest to 0. It gives you the solution closest to 0. So it's going to give us this angle here. So if you press that, you should get 30 degrees on your calculator. Need to make sure your calculator's in degrees mode. I'm going to be doing all the questions in degrees. That's the first solution. Theta equals 30 degrees. And then to get the other solutions, you can use the sort of like the symmetry of the graph and the fact that it repeats every 360 degrees. These peaks are sort of symmetrical and the same. So 30 degrees is there. So that's a gap of 30 degrees. So that's also a gap of 30 degrees. And so is that, and so is that. So this angle here is 180 minus 30, which is 150 degrees. So that's the next solution. This angle here is 360 plus 30, which is 390 degrees. And this angle here is 540 minus 30, so it's 510 degrees. So you can just use the symmetry of the graph to get the other solutions, once you've got the first one. Right, let's do an equation involving cos. Let's solve cos theta equals 0.6, looking in the range from, let's go all the way from minus 180 up to 540. So we're looking for angles in the range from minus 180 all the way up to 540 with a cos value of 0.6. Again, you can't read it straight away off the graph. You can get an idea of where the solutions are going to be just by drawing a dotted line roughly at a height of 0.6. So there's going to be one solution here, one here, one here, and one here. But again, to get us started, you need to get your first angle from the calculator. So you press inverse cos. You just press inverse cos 0.6, and that will give you an angle with a cos value of 0.6. When you press inverse cos, the calculator gives you the solution with the smallest positive solution when you press inverse cos. So it's going to give you that angle there. And if you press that, you're going to get 53.1 degrees, which is that angle there. Again, we can use the symmetrical properties of the graph and the fact that it repeats, because if that is 53.1, it means that that is minus 53.1. So we've got two solutions already, 53.1 and minus 53.1. These two angles are both 53.1 away from 0. So because the graph repeats, that means that these two angles, here and here, are going to be 53.1 away from 360. They're sort of 53.1 either side of 360. So this angle here is 360 minus 53.1, which is 306.9. And this angle here is 360 plus 53.1, which is 413.1. So those are the four solutions to that equation. Let's just do one more using the graphs. Like I said, solving using the graphs is not the main focus of today's lesson. I'm going to show you another method after this last example. But let's do one more using the graphs. Let's solve tan theta equals 1. Looking in the range, let's go all the way from minus 90 all the way up to 450. Solve tan theta equals 1 from minus 90 to 450. Again, you can get an idea roughly of where the solutions are going to be. Imagine drawing a dotted line at a height of 1. So there's going to be one solution there, one solution there, and one solution there. Again, to get us started, to get our first solution, you need to press inverse tan. So if you press inverse tan of 1, the calculator will give you an angle with a tan value of 1. Inverse tan of 1. If you press inverse tan, it gives you the solution that's closest to 0. So it will give you that angle there. So if you press that, you should get 45 degrees. So that's our first solution, 45 degrees. So because that's 45 degrees, you've got a gap of 45 there. And the tan graph repeats every 180 degrees. So these curves repeat every 180. So this is also going to be a gap of 45, and that's also going to be a gap of 45 as well. So this angle here is 180 plus 45, which is 225. And this angle here is just 360 plus 45, which is 405 degrees. So that is how you solve trig equations using the graphs. Right, so we've solved a few trig equations using the trig graphs. But when I solve trig equations, I don't usually draw the graphs. I find it's a bit tedious to draw a graph every time. So what I'm going to do now is I'm going to show you a quicker method for solving trig equations where you don't need to draw a graph at all. And I'm going to explain this method using the unit circle. So in lesson 2, if you remember, I introduced you to a unit circle. It's just a circle of radius 1, centred at the middle of the quadrant diagram. If you remember, in a quadrant diagram, angles are measured sort of anti-clockwise from this horizontal line, so that would be 90, 180, 270, 360 and so on. And you can go going the other way gives you negative angles, like from there, minus 90, minus 180, minus 270, minus 360, and so on. And last lesson I showed you that if you draw them if you draw the angles inside a unit circle, something interesting happens. So, for example, if I just mark a sort of a general angle, I'll call it theta. Let's do it in the first quadrant. Let's call this angle theta. Measured from this horizontal line, it's an acute angle. And let's say I drop a line down. Because I've drawn it inside a unit circle, that means that the height of the triangle is actually sine theta. This height is actually sine theta. And the base of the triangle is actually cos theta. So when you draw the angle inside a unit circle, the height of the triangle is sine theta, the base of the triangle is cos theta, and the gradient of the slope is tan theta. So you get a really nice way of picturing sine, cos and tan if you draw the triangle inside a unit circle. So sine theta is the height, positive if going up, negative if going down. Cos theta is the base, positive if going to the right, negative if going to the left. And tan theta is sort of like the gradient of the slope. Positive if sort of sloping that way, negative if sloping that way. Just as an example, I'll do a sketch of an angle. So imagine I measured 60 degrees from this line, so to there, let's say, 60 degrees. And this was a unit circle of radius 1. Unit circle, so I drop a line down. So because it's been drawn in a unit circle, this height would be sine 60. And if you do that on the calculator, you get 0.87. 0.87. Remember, the whole radius is 1, so that would be 0.87. Cos theta is the base of the triangle. So cos 60 in this case would be, if you do it on the calculator, you get 0.5. 0.5. Remember, the whole radius is 1, so that's 0.5. And tan 60 is the gradient of this sort of sloping line. Tan 60. And actually, if you check that on the calculator, it's 1.73. If the angle was 45 degrees, the gradient would be exactly 1. Because the angle is more than that, the gradient is a bit more than 1. So tan 60 is the gradient of the slope. So we're going to use these ideas to help us find all the solutions to trig equations without having to draw the graphs. So let's move on to some trig equations now. The first one's going to be solve sine theta equals 0.8, looking between, let's look between just 0 and 360. So let's try and solve this equation without drawing a graph. Well, to get the first angle, to get the first solution, you have to use the calculator. You have to press inverse sine 0.8. So if you press inverse sine 0.8, the calculator will give you an angle with a sine value of 0.8. It will give you one of the solutions. It gives you the solution closest to 0, always, when you press inverse sine. So if you press that, you get 53.1 degrees, and that's in range, so we can take that as our first solution, 53.1. And now we can use the unit circle idea to find the other solutions. So I'll just sketch a unit circle, like that. Let's mark 53.1 where it is roughly. So that's 0. So 53.1 is in the first quadrant, maybe roughly there. Just a sketch, 53.1. Remember, this is going to be a unit circle. I'll just make that clear by writing radius equals 1. You drop a line down, you get your right angled triangle. So this angle has a sine value of 0.8. In other words, the height of the triangle is 0.8, because the height of the triangle in the unit circle is just the sine value of the angle. So we're looking for other angles also with a sine value of 0.8. So if I could draw another triangle with the same height, another triangle with a height of 0.8, that would help me find other solutions. So how can I draw another triangle in this unit circle with the same height? Well, I could just reflect it across. I could just reflect this triangle across, and then I'd have another triangle with the same height, also with a height of 0.8. So that gives me my next solution. If I go around in a positive direction, my next solution is just there. It's just this angle here. This angle has the same sine value of 0.8. So what angle is that one? Well, it's almost 180 degrees, but there's this gap of 53.1. So it's 180 degrees minus 53.1, which is 126.9. So that's the next solution. And if I kept going round until I got back to this line, that would be my next solution. So my next solution would be 53.1 plus another 360, but unfortunately that's out of range. So you can actually keep going round and round and round, adding 360 to these solutions to get more and more until you get to the end of the range. But in this case, these are the only two solutions because the range only goes up to 360. Let's do another example. Let's do another equation. Solve sine theta equals 0.4. This time we'll go up to 720. Okay, so to get the first angle, you press inverse sine 0.4 on the calculator. So you press inverse sine 0.4, and that just gives you a solution for free. It sort of gives you the one closest to 0 when you press inverse sine. And you get 23.6 if you do that, 23.6. That's in range, so we can take that as our first solution. But there are going to be quite a few solutions here, because we can go all the way up to 720. I'll just draw a sketch of the unit circle. So unit circle radius 1. And I'll just mark 23.6 roughly where it is. I'll actually make it a bit bigger than it is so it's clearer. But as long as you get that it's in the first quadrant, that's the main thing, 23.6 there. And that's the triangle. So this, the 23.6, this angle has a sine value of 0.4. In other words, this height is 0.4. So I'm looking for other angles with the same sine value. So if I can draw another triangle with the same height, that will help me find other angles with the same sine value. So just as we did up here, to draw another triangle of the same height, you reflect it across. So there we go, that's another triangle with a height of 0.4. Well, so the next angle, if I go around in this positive direction, the solution is that angle there. So this is the next solution. So what is that angle? Well, again, it's the same method. It's almost 180, but there's a gap of that angle there. There's a gap of 23.6, so it's just 180 minus 23.6, which is 156.4 degrees. So if you've got an equation sine theta equals something, to get the second angle, you always subtract the first angle from 180 degrees. So once you know that, you don't really need to draw these pictures anymore, you can just do that straight away. You get the first angle from the calculator, then you subtract it from 180 degrees to get the second angle. So are they the only two solutions? Well no, because we can go all the way up to 720, so we can actually go round again. So we can do all the way round and then get back to the line. So this angle is 23.6 plus another 360. So you can add 360 to that angle, and you get 383.6. And you can also do this angle here, which is 156.4, plus another 360, and you'll get back to the line again. You can add 360 to that angle, and you get 516.4. So those are the next two solutions. And unfortunately you can't go round again because you go above 720. If you added 360 to either of those, you go above 720. So you have to stop when you get to the end of the range. Right, let's do an equation involving cos. Right, let's do, as I said, let's do an equation involving cos. My next one is going to be solve cos theta equals 0.7. And let's do the same range that we just did. Let's go from 0 all the way around to 720. So that's like 2 full turns on the unit circle. So let's solve that equation. Again, to get the first angle, you need to press inverse cos. You need to use the calculators. You press inverse cos of 0.7. And the calculator will give you the smallest positive solution when you press inverse cos, which in this case is 45.6 degrees. That's in range, so we can take that as our first solution. We can accept that, 45.6. Let's use the unit circle to find other solutions. Again, after a while, when you know what's going on, you won't need to draw the circle every time, but this is just to show you what's going on. 45.6 is here roughly. 45.6. Drop a line down, you've got your right angle triangle. This is a unit circle of radius 1. Now the cos value of an angle is just the base of the triangle. So this angle has a cos value of 0.7, which just means that this base length here is 0.7. I'm looking for other angles with the same cos value. So if I can draw another triangle with the same base, that will help me find other angles with the same cos value. So how could I reflect this triangle to get another triangle with the same base? Well, I don't want to reflect it that way, because that would have a sort of a negative base. That would give me angles with a cos value of minus 0.7. I want to reflect it down. If I reflect it down, I'll get another triangle that shares the same base, and that will give me other angles also with a cos value of 0.7. So continuing in a positive direction, the next angle is going to be there. It's going to be round to there. So what is that angle? Well, it's almost a full turn. It's almost 360, but it's 360 minus that gap, which is 45.6. So it's just a 360 take away 45.6. Which is 314.4 degrees. So we've got two solutions there. Can we go round again? Well, we can, because the range goes all the way up to 720. So you could just get back, so 45.6 was the first solution. You could just do a 360 turn and you get back to that line. So you can add 360 to this solution to get the next one, which is 405.6. And you could add 360 to that one as well, and you get 674.4. You couldn't go round again because the range only goes up to 720. So these are the four solutions. So notice with sine, to get the second angle you subtract from 180. For cos you always subtract from 360 to get the second angle. Again, once you know that, you don't really have to draw the picture at all. Let's do another one with cos. Let's do solve cos theta equals 0.4. I'm going to use a slightly different range now. I'm going to go from minus 360 up to 360. So using a slightly different range. So again, to get the first angle, you press inverse cos 0.4 on your calculator. And you get 66.4 degrees. That is in range, so we can take that as our first solution. So 66.4 degrees. Again, let's use the unit circle idea to find the other solutions. 66.4 is anti-clockwise round about there. 66.4 degrees. This is a unit circle, radius 1. I'll just write that every time to make it clear. And the cos value is the base of the triangle in a unit circle. So this angle has a cos value of 0.4, just means this base is 0.4. I'm looking for other angles with the same cos value or same base. So can I draw another triangle with the same base? I can, you just reflect it down. So for cos you reflect it down to get another angle with the same positive base. So the next solution, going in a positive direction, the next biggest solution, is this one there, is this angle here. Again, you can see it's 360 minus 66.4. So for cos, to get the second solution, you always subtract the first one from 360. For sine, you subtract from 180. So it's 293.4. So we've got two solutions there. Now we can't add 360 to these because we'd go out of range, we'd go above 360. But we can actually subtract 360 from both of these. Imagine you're at 66.4 and you take away 360. That would get you back to that line and give you another solution. So you can take away 360. You can take away 360 here. And you get minus 293.4 here. And here you'd get minus 66.4. You couldn't take away 360 again because you go below minus 360. So those are the four solutions for this range. So for my next equation, I'm going to do a sine theta equation. so going back to sine theta, but I'm going to stick with the range minus 360 to 360. So the equation is sine theta equals 0.3, looking for solutions in that range from minus 360 to 360. So to get the first solution, you just press inverse sine. So you do inverse sine 0.3, and the calculator will give you the solution closest to 0, which in this case happens to be 17.5. That's in range, so we can accept that as our first solution. So the first solution is 17.5. Now how do you get the next biggest solution after that? Well, when it's a cos theta equation, you subtract the first one from 360. When it's a sine theta equation, you subtract from 180. So you do 180 take away 17.5. That always works, and you get 162.5. If you don't happen to remember that rule, you can always just draw a unit circle at the side to find this angle, because the calculator gives you the first angle, 17.5, which is over here. And from that you can work out what the second angle is. Because the sine value of an angle is just the height of the triangle, so we need to draw another triangle with the same height. You can always do that by reflecting this one across. So this triangle has the same height, so this angle up to here will have the same sine value as 17.5. And hopefully you can see from the picture that to work this angle out, you do 180 take away 17.5, which is 162.5. So we've got two solutions here. Are they the only solutions? Well, the range is from minus 360 to 360. So you can't add 360 to either of those because you'd go above 360, but you can subtract 360 from them. So you could subtract 360 from this one. That's because 17.5 take away 360 will get you back to the same place. And you'd have a negative angle of minus 342.5. And then if you subtract 360 from this one, you get minus 197.5. So minus 197.5. So there are four solutions altogether. So for a sine theta equation, you press inverse sine to get the first solution. You then, to get the next biggest solution, you subtract it from 180. That always works. And then once you've got that first pair of solutions, you can keep adding or subtracting 360 to get more and more solutions until you get to the end of the range. For a cos theta equation, it's exactly the same, except after you've got the first angle, to get the next one, you subtract from 360 instead of 180. But you can always draw a unit circle at the side if you don't remember the rule. So what I'm going to do now is I'm going to do a couple more equations with sine and cos, but where there's a negative angle, where there's a negative number on this side. So let's see what happens. So the method I just described for solving these equations, does it work when you've got a negative number here? Well, let's see. So let's put minus 0.4 here, and let's solve this equation. So solve sine theta equals minus 0.4. Let's keep the range simple. Let's go from 0 up to 360 degrees. So is it exactly the same method? Well, let's see. Well, to get the first angle, you do exactly the same as before. You have to press inverse sine. This time you need to press inverse sine of minus 0.4. And the calculator will give you an angle with a sine value of minus 0.4. It'll give you the one that's closest to 0, which happens to be negative this time. So it will actually give you the angle at minus 23.6. Now notice that's not in range. That's not in this range. It's smaller than 0. So we can't accept it as a solution. Normally we just write it down as our first solution, minus 23.6, and just carry on. But here we can't accept it because it's not in range. So I'll just make that clear. I'll write not in range. But we can actually use it to find other solutions. So we can actually mark it on the unit circle and use it to find other solutions. So where is minus 23.6? Well, from 0, it's 23.6 clockwise round. So it's you measure negative angles by going clockwise. So this is minus 23.6, somewhere there. And this angle has a sine value of minus 0.4. In other words, the height of the triangle is minus 0.4. It's 0.4 going down. I'm looking for other angles with the same sine value. So can I draw another triangle in this unit circle with the same height? Well, yes I can if I reflect this triangle across. So for sine you always reflect the triangle across, and now I've got another triangle with the same negative height. I'll just write radius 1 to make it clear that this is a unit circle. So the next angle going this way around is going to be there. Now I said earlier for sine, you can always take the first angle away from 180 degrees to get the second angle. Does that still work here? Can I take away minus 23.6 to get the second angle? Well, let's have a think what this angle is. This angle is 180 plus an extra 23.6. Well, adding 23.6 is the same as taking away minus 23.6. So it does work. It will still give me the same answer. It gives me the answer of 203.6, which is what this angle is. So for sine, you can always subtract the first angle from 180 to get the second angle, even if the first angle is negative. Now, is that it? Or are there other solutions? Well, actually, there are other solutions, because you could add 360 to this angle, and this will give you an angle in range. So if you add 360 to that, you get 336.4, which is in range, and you could add 360 to that one, and you'd get, oh, that would be too big, you get 563.6. So this is in range, but this is not in range. So for sine, you subtract you press inverse sine to get the first angle, and then you can always subtract it from 180 to get the second angle. And then once you've got that pair, you just keep adding 360 degrees or subtracting 360 degrees until you get to the end of the range. Let's do an equation with cos theta and a negative angle on the right hand side. Let's do cos theta equals minus 0.2, and this time let's go from 0 up to 720. Okay, so again, to get the first angle, you just press inverse cos on the calculator. You press inverse cos of minus 0.2. Now actually, when you press inverse cos, the calculator never gives you a negative angle. It always gives you the smallest positive solution, which in this case is actually 101.5. So that's the angle it gives you. That is in range, so we can take that as a solution. Now for all the other examples, for cos, to get the second angle, we subtracted from 360. So is that going to work this time? Well, let me just draw a unit circle just to see if that works. 101.5 was our first solution, and where's that? Well, that's 90, it's a bit further than that. So it's about there, that's 101.5. If you drop a line down, you get your right angle triangle. Remember, this is a unit circle, radius 1. So this angle has a cos value of minus 0.2, which just means the base is of length 0.2 going to the left. It's minus 0.2. So I need to draw another triangle with the same base if I want to get other angles with the same cos value. So to draw another triangle with the same negative base, I just reflect it down. So for cos, you always reflect down. So that's the triangle with the same base. So the next angle I want is going this way round, is this angle here. So it's that angle there. And hopefully you can see that this will work, because this gap here is 101.5. So that angle marked red is 360 take away 101.5, which is 258.5. So for cos, you can always, to get the second angle, subtract the first one from 360. That always works. And because the range goes up to 720 here, we can add 360 to both of these. In other words, we can go round again. So you can add 360 to this one, and you can add 360 to that one. And here you'll get 461.5, and here you'll get 618.5. So those are the four solutions. Right, now I'm going to do three equations involving tan theta. This is actually a bit easier than the sine theta or cos theta equations, as you'll see. It's easier to find the solutions. So solve tan theta equals 2. And let's look from 0 up to 720. So we're looking for angles with a tan value of 2 in the range from 0 to 720. To get the first angle, again you have to use the calculator. You just press inverse tan. So you press inverse tan of 2, and that will give you an angle with a tan value of 2. It gives you the one that's closest to 0. It gives you 63.4 if you do that on the calculator. That's in range, so we can accept that as our first solution. Let's use the unit circle to find other solutions. Just do a sketch. So where's 63.4? Well, it's over there roughly. So 63.4. Drop a line down, there we go. So the tan value of an angle is just the gradient of the slope. It's just the gradient. So this angle has a gradient of 2, this slope. So I'm looking for other angles with the same tan value. So it'd be good if I could draw another triangle also with the same gradient, with a gradient of 2. So how could I draw another triangle whose slope has the same gradient? Well, I could actually just rotate this one round to here. Or even easier, just extend this line. Just extend this line so it's got the same gradient, and then draw a line up to the horizontal. So that's another triangle whose slope has the same gradient as this one. So the next angle I want, going in the positive direction, is this angle round to there. This angle here. So what is that angle? Well, it's 63.4 plus 180, because you just do a half turn to get to this line. So you just add 180 to this one. So add 180 to get the next angle, which is 243.4. Now notice the range goes all the way up to 720. So from here, from 243.4, I can just add 180 again and get back to the original line. So I can just add 180, and that'll be another solution, which will be 423.4. And then I can even add 180 to that again, and I'll get to add 180, that'll be 603.4. If I add 180 to get again, I'll go above 720, so I'll be out of range. But these are the 4 solutions. So for tan, it's really easy. You just get the first solution on the calculator, and then you just keep adding 180, or sometimes subtracting 180. If the range was going the other way, you'd subtract 180 to get all the solutions until you get to the end of the range. So let's do another one. Let's do solve. Let's do tan theta equals 0.5, looking from minus 360 up to 360. So again, just like before, you press inverse tan 0.5, inverse tan 0.5, and the calculator will give you an angle with a tan value of 0.5. Again, it gives you the one closest to 0, which is, I think, what is it, 26.6, I think? Yeah, 26.6 it says there. 26.6. That is in range, so that is our first solution. Now for tan, as I said, you just keep adding or subtracting 180 to get other solutions. Just wondering whether to draw a picture. I mean, it's basically the same as that. I might as well draw it. So 26.6 is over here. 26.6 degrees. It's got a slope with a gradient of 0.5. So this gradient is 0.5. The other triangle with the same gradient is just over here. Just extend the line. So the next angle we want is just 180 round from this angle. So you just add 180 and you get 206.6. Can we add 180 again? No, we'll go above 360, but we can subtract 180. So from the original angle, 26.6, if you go back 180, you'll get a negative angle that will be in range. So subtract 180. You get minus 153.4, and you can even subtract 180 again, and you get minus 333.4. So it's a bit messy, but these are the 4 solutions. I guess you could write them neatly in a line underneath, but I'll just leave it like that for now. Those are the 4 solutions. So let's do one more tan equation. Let's solve tan theta equals -3. Let's look from 0 to 720. So this time we've got a negative number on the right hand side of the equation. It doesn't change anything though. To get the first angle you press inverse tan of -3. And it will actually give you a negative angle. It gives you -71.6. When you press inverse tan, it just gives you the solution closest to 0. Sometimes it might be negative. But here it is. Now that's not in range, so we can't accept that as one of the solutions. Normally you just write that down, -71.6, and just carry on. But here we need to cross it out, because it's not in range. But we can use it to find other solutions. Remember, for tan you just keep adding 180. I'll just do a picture again. So -71.6 is just 71.6 clockwise, so it's just over there, -71.6 degrees. It has a tan value of -3, which just means the gradient here of this sloping line is -3. To draw another triangle with the same gradient, I can just extend this line and then drop a line down to the horizontal. So, because I'm only allowed positive angles, the next angle that I want really is this angle plus 180. So, the next angle is, you just add 180, which is 108.4. That's in range. And actually, I'll only go to 360. It'll take a bit too long going to 720. I'll just stop at 360. And then the next angle after that, you can add 180 again, and you get to 288.4. 288.4. So these are the 2 solutions. So I'm going to do one more equation today. It's on the board. It looks a bit more complicated than the other equations we've done so far. I'll just read it out. It says 3 sine theta plus 4 equals 5. And we're looking for solutions in the range from 0 to 720. And it looks a bit more complicated because before we find some solutions, we need to do a bit of rearranging. We basically need to get sine theta on its own, and then you'll see it's actually like all the other ones we've done today. So let's try and get sine theta on its own. So we could start by getting rid of the plus 4 by taking away 4 from both sides. So you get 3 sine theta equals 1. And then you could just divide both sides by 3, and that will get sine theta on its own. So you'll get sine theta equals 1/3. So as you can see, it's just like all the other equations we've done today. To get that first solution, you just press inverse sine of 1/3. So you do inverse sine of 1/3. And if you do that, you'll get 19.5 on the calculator. So 19.5. And that is in range, so we can take that as our first solution. So theta equals 19.5 is the first solution. Now for an equation with sine theta, do you remember how to get the second solution? That's right, you subtract the first one from 180. So you do 180, take away 19.5 to get the next biggest solution, which is 160.5. Now if you don't remember that rule, it doesn't matter. You could just use the unit circle to help you. So if you remember, you can just draw a unit circle. 19.5 is just over here, roughly, 19.5. Drop a line down. And the angle has a sine value of 1/3. Just means the height of the triangle is 1/3, because the height of the triangle is the sine value in a unit circle. And we're looking for other angles with the same sine value. So I just draw a triangle with the same height. So and you can always do that by reflecting across, and you get another triangle with the same height. So from the picture, the next angle we want is just this angle here. This angle has the same sine value as 19.5 because the triangle is the same height. And hopefully you can see from the picture that to get that angle you just do 180 take away 19.5. So if you don't remember this rule, you can always just quickly draw a unit circle to help you find the other solutions. There are the first 2. Are there any more solutions to this problem? Well, yes, there are, because we can go all the way up to 720. So we can go round again. So to both of these angles, we can add 360 degrees. So we can add 360 to both of them. So the next two solutions are 19.5 plus 360, which is 379.5, and 160.5 plus 360, which is 520.5. So 4 solutions altogether. So that's it.